Hi everyone. Today I and Molwats I'm going to talk about the fish project. Now before jumping to the code, let us talk about the problem statement. Herein we need to simulate a school of fishes exhibiting a swamp behavior where a leader moves in a random way and other fishes follow the neighbors with also some random factor. Fishes can also recognize the presence of a predator so that they can escape from it, and the predator can be introduced and animated by the user via the mouse pointer. So now to the files, we have a make file so that we need not always put the large allegro and gcc g++ commands. It makes our lives easy. So for that we have the make file. Then we have a main file which is the swamp.cpp. We have the swamp executable. We have two header files for easiness of the code, which is type.h and realtime driver.h, and correspondingly two linker files. Now both header files have allegro and the scheduler or the threads each in each. For example, in case of header file, real-time driver file, we have threads and scheduler, wherein the types file, header file, we have allegro. So let's open it first. The real-time drivers has the task parameters, the insertion of periodic task and ending of scheduler, then deadline management, etc. Then we have in the real-time driver.cpp, which is the linker file, it imports this header file as well, and it talks about how the scheduling will be done. So herein we have used the kernel scheduling to be schedule FIFO, which means that kernel is using the FIFO scheduling algorithm to minimize the interference of the kernel in our own program so that we can manipulate it easily, we can customize easily. Now we have also used RM, which is rate monotonic, to analyze the threads. Sorry for the notification. And to analyze the threads, and that analysis will be done on the basis of the arrival of the task, which is again by first come first serve. This is done because the since the task period, the time period of all is same, the base time period is same, that's why the priority is same. So whichever thread comes first will be executed first. So then there is a function for deadline miss, then wait for time period, right? So herein in the in order to herein we have the task parameters and arguments, and then we have the types.h, which is basically all about allegro, all about graphics, the screen width, the maximum number of speed, the number of particles. We have vectors wherein we have the formulas. Then we also have the classes of both fishes and predators. Fishes again into both leader and normal fishes are belonging to the same class of particles. Then we have the .cpp folder again, which talks about, extends and includes types.h, and then it talks about alignment, cohesion and separation. So alignment is basically aligning, and then cohesion is to avoid any sort of cohesion, and separation is to avoid any sort of collision, and move together, they can be used to move together. This is something we got to know via some BBC reports on fish and school of fishes, so that's why we included it here. Then we have all this is basically the drawing of the fish, and that's it. Then to the main file, we have extended, we have included both these types.h and real-time drivers. Then we have that's where we have the state of mouse, then move functions like moving the fishes, task which moves the of fishes. Then we have display managers, and then we have obviously the main function, wherein we can see that the both are deadline and period are both the base periods, which I was talking about earlier. So this is the code, and now we'll go back and we'll run the code. So first of all, this is the ls. Here we can cat the make file. And that's what I was talking about in the first place, that instead of using this every time, we can just use another a command which I'll use to execute it later on. All is what it will execute, and clean is basically to remove the executable file, which is the swarm.ext. So in order to make that file, I'll run this, and this is what it is. The green ones are the leaders, and this mouse pointer is the predator. The rest are the fishes. You can see that they aligned themselves, and I can use to disperse them. So the initial, though the every time we use and start the executable file, the initial positions of the fishes will be random, but then the other positions, I mean the speed, the number of particles are hard coded and will be the same. So this is the simulation, the final simulation. And once we stop the movement of the predator, we can see that they have been aligning themselves into groups, with each group having a leader. We can see that in green, and they're moving together. So we can see here are green, and then we can disperse them. So that is the simulation. And once we end the simulation, we can see that the logs come up, the threads come up. So I hope you like this small presentation or a video of the project, and thanks a lot for watching till now. Thank you. Signing off, Anmol Vats.